So 7.6, we have similarity transformations and a dilation. Dilation is a transformation that enlarges or reduces the original figure proportionally. And a scale factor of dilation. Oh, I can't fit this. Let's see. Scale factor of dilation. Okay. Scale factor of dilation, K, is the ratio of a length on the image to a corresponding length on the pre-image. And a dilation with a scale factor greater than 1 is an enlargement. And a dilation with a scale factor K, that's less than 1 but greater than 0 is a reduction. And so for these examples here, we're supposed to determine whether the dilation from figure A to figure B is an enlargement or a reduction, and also find the scale factor of dilation, find the K. So here we are. We have the figure A, we have figure B. Well, it's pretty obvious that A is smaller than B, so we are enlarging from A to B. So we're going to say enlargement. And we can verify that by figuring out what the scale factor is. So I'm going to say K is equal to, let's go ahead and choose this bottom of the figure, and we're going to say 2 over, and then we're going to use the bottom of the second figure, 4. So it's equals to, oh, I'm sorry, no, this is the other way around. To find the scale factor, we put the side of the image over the corresponding side of the pre-image. So we're going to say 4 over 2. So the scale factor is 2. And so we have an enlargement because the scale factor is greater than 1. So let's go ahead and try this one. We have figure A to figure B. Well, it's obviously a reduction. It's getting smaller. Reduction. And we need to figure out what the scale factor is. So we're going to get the side. So this side here, the left side of the triangle B, is easy to calculate. It's 1, 2, 3. So we're going to do 3 over the corresponding side of triangle A is 1, 2, 3, 4, 5, 6. So here our scale factor is 1/2. So it's obviously a reduction. And so down here, we're supposed to verify similarity. And so we could verify that a dilation produces a similar figure by comparing all sides and all angles. But we can also use a shortcut. So for triangles, we can use SAS. Right? How do we do that? Well, an angle needs to be congruent in both triangles. And then the included sides of the angle need to be proportional, right? And remember, we can also use SSS, where all of the sides need to be proportional, or corresponding sides need to be proportional. And we could also use AA. So if we have two angles that are congruent in two figures, then we could say that they in two triangles, then we can say that they're similar. Right? So we can use all of these methods. So let's go ahead and try this one. We have this is the original figure, and here is the image. So let's go ahead and use SAS because we have an angle, and then these sides are very easy to calculate the length of. We could just look at the figure, right? So the angles are congruent, that's for sure. And so AC is going to be equal to 4 and 4, so that's 8. And then the corresponding side over here would be DF. And DF is going to be equal to 1, 2, 3, 4. And then we have this side up here, so we're going to say AB is equal to 5. And the corresponding side would be DE, which is equal to 3. So what we need to do is check if they're proportional. So we're going to say 8 over 4. We're saying this side over this corresponding side here, 8 over 4, is equal to this side over the corresponding side here, DE. Right? So we're going to say 4 over 3. So let's go ahead and check that proportionality, see if it's true. So it's going to get 24 is equal to 16, and that is not true. So they are not similar, right? So I'm going to say triangle ABC is similar to triangle DEF, and I'm going to go slash right through it and say nope, not similar. Okay. So over here, we don't have any angles congruent. So we want to use side, side, side to prove that the two figures, the two triangles, are similar, right? And so this is going to be a long one. Buckle yourself in. To do side, 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 we need to figure out the length of all of the corresponding sides and check that they are proportional. So let's go ahead and start with GH is equal to the square root of -4 minus 0, so -4 squared, and then plus 1 minus 4 is squared, so -3 squared. So that's going to equal to square root of 16 plus 9 equals square root of 25. Okay, and then let's do the corresponding side, LM. So let's do LM is equal to the square root, L and M. So -2 squared plus -1.5 squared. So what is 1.5 squared? Uh, 225. Okay. So it's going to be square root of 4 plus 2.25, so square root of 6.25. Okay. And then what? Now we want to do the bottom of the triangle, so we're going to do GJ. GJ is equal to the square root of, oh no, we already know GJ. We could just count it. 1, 2, 3, 4, 5, 6, 7, 8. And then the corresponding side would be LN, and we can count that as well, so that'd be 4. And then lastly, we're going to do the last sides. It's going to be HJ is equal to, and here we need to do the square root. So HJ, so let's do 4 squared plus a -3 squared is equal to square root 16 plus 9 square root 25. Okay. And then we're going to do the corresponding side on the small triangle. It's going to be MN is equal to square root MN. It's going to be 2 squared plus a -1.5 squared. So that's going to be the same thing, square root 6.25. Okay. So now we check the proportions and see if they are equal. So we're going to say these two, right? These two sides, corresponding sides, are equal to those two corresponding sides over each other. And then we're going to do these two sides over each other are equal to those two sides over each other, right? We can check all the proportions. So let's go ahead and do that. We'll do square root 25 GH over LM is equal to over square root 6.25 is equal to the next two. So we're going to do square root 8 over 4. And, oh no, I need a calculator for this. Oh, actually, square root 25 is just 5, right? So we could just say 5 over there. Okay, so let's go ahead and check this out. So it's going to be 20 is equal to square root 8 times square root 6.25. Is that true? Let me break open my calculator. So, square root 8. Do I have a square root? Yes, square root 8 times square root 6.25. And that is not true. This is equal to 7.07. So let's double check that I did this correctly, because the triangles look similar. Did I do this right? We're doing GH over LM is equal to, oh, it's not square root 8. Oh my gosh, shoot, it's 8. And that's still not true. So let's do 8 times square root 6.25. Oh, that is true. It's 20. Okay. So if we're doing 8 times square root 6.25, then it does equal to 20. Okay, so far so good, right? And then we are going to now check, let's do these two and these over these two, right? So let's do 8 over 4 is equal to square root 25 over square root 6.25. And these are actually the same proportions as over here. So it's going to become 20 is equal to 20. And so we can say that the two triangles are similar, and of course we're going to end our problem with a similarity statement saying triangle GHJ similar to triangle LMN, like so. I'll box that. Okay, so anyhow, sorry about that, but you are to do the problems on the back.